Alright, my name is Joshua. Eric is not present. This is our math seminar. I hope you enjoy the presentation. Let me get my laser pointer out and ready right here, right before we start. Alright, so Mr. Shin's smartwatch measures his stress, which is modeled by the function s at t equals t squared plus sine times t times 2 to the power of t. The time in t, measured in months from September 1st, 2022, is represented by t equals 0. The stress level of Mr. Shin, S at t, is measured in stress units. So when S of t is greater than 0, Mr. Shin is stressed, and when S at t is equal or less than 0, Mr. Shin is not stressed. So the questions: A. Determine his average rate of change between t is an element of 0 to 3. Round to the nearest thousandth. And what does the average rate of change represent? B is the same thing, but now we have to calculate the instantaneous rate of change at 2.1. So C, D, and E are all other questions. C asks to compare and contrast your answers in part A and B. So the difference between AROC and IROC. D is what could have caused Mr. Shin's stress changes in parts A and B. E is why do characteristics of certain individual functions disappear and appear. So key information. We have our two functions, S at t, or no, just one function, S at t. B, we have to calculate AROC. C, IROC. D, compare and contrast. E is come up with a theory as to why Mr. Shin is stressed. And F is talk about characteristics. So A, determine his average rate of change between t as an element of 0 to 3. So 0 meaning September, the start of the year, all the way to 3. So in the domain, t is an element of 0 to 3, t2 equals 3, and t1 equals 0. That is going to be involved in our AROC formula right here, which is delta S over delta T. So we split that up, you have S T2 minus S T1 over T2 minus T1. Go further down, input these values, now you have 3 minus 0. But you have to put in the S function. So we open that up into 3 squared plus sine bracket 3 times 2 to the power 3 subtracted by 0. So all of this is just going to be forgotten about because there's zeros everywhere. 3 minus 0 is still 3. So 8.094 minus 0 over 3 is 2.698 stress units per month. We have to make sure that we use the approximation symbol because we're working with decimals here. And another thing to think about is whether your calculator should be in radians or degrees. Radians because we're working with trig functions such as sine. So therefore, the AROC of Mr. Shin's stress level over the course of 3 months is at approximately 2.698 stress units per month. Question 2. When t equals 2.1, we have to calculate the instantaneous rate of change. So IROC is essentially the same formula, but now instead of delta S over delta T, we're doing delta Y over delta X. It's essentially like slope. So IROC, put in those two values, 2.1, but here's the catch. We have to use a number that is, what is that? Let's see, tenths, hundredths, thousands, 100,000s. You can use thousands or 100,000s, and you have to choose a value that is just slightly above t equals 2.1 or less. In this case, we use a value less than 2.1 by 1,000th. So 2.1 minus s of 2.099, same with the denominator. We have these very big values because remember we have to input s into the top part for every time you see an s. So that decimal is 4.819 subtracted by 4.82 over 0.001. This answer, when you calculate the top, should be really, really small, which is why when you divide by this, you move the decimal place back to right. You should be left with a negative number of negative 5.401 stress units per month. Therefore, the instantaneous rate of change stress levels are at 2. Therefore, the instantaneous rate of change stress levels at t equals 2.1 is approximately negative 5.401 stress units. This is another way to do it. This is 2.1001. And since that value is bigger, we put that in front of 2.1. So C, compare and contrast your answers in part A and B. So we have two graphs. This is A rock. Well, actually, it's the same graph, but one demonstrates A rock, the other is I rock. So similarities. A rock and I rock uses the exact same formula. We debunked this earlier. However, some differences. A rock represents the average rate that Mr. Shin's stress is increasing within 3 months. So we have 0. And we have all the way up to 3. Looking at that sine wave, that's a little wonky because it's also exponential. The average line that the stress level would look like is A rock. I rock represents the stress level of Mr. Shin at a specific time. So I rock would be this, because specifically at 2.1, which would be right here, that is where his stress is at. So this line should be parallel with the point that I rock is asking for right there. So substitute different t values in A rock. Substitute t values 3 and 0, but in I rock, substitute t values 2.1 and values 0.001 higher or lower than 2.1. And E, one more. A rock has a positive slope, while I rock has a negative slope. Okay, so D, here's some theoretical answers as to why Mr. Shin's stress levels are increasing. This is related to A-Rock. So we made a theory that his stress level slowly increased as the months approach November. Some theories are that teachers need to submit all their midterm marks by the middle of November, requiring them to mark many assessments. Another theory is that teachers may also need to consider how they're going to prepare students for their final exams early on in the semester. I guess they really want to be ahead. And since November is the month before December, Mr. Shin's stress level may gradually increase due to the fact that he has to worry about purchasing Christmas gifts. Alright. As for Part B, I rock. A strike was announced specifically on that day. Eric, who is my group member, did a lot of crazy math for it. 2.1 months from September 1st is November 3rd, the day that YRDSB announces a strike. So Mr. Shin did not need to attend work on that day. He gets to stay at home. That was like me today, sitting in my chair for the whole day because of inclement weather. This also provides him with an extra time to mark assessments and relax at home. Oh, the proof is right here, November 4th. One more question. E. Why do key characteristics appear and disappear? This part, myself, a little wonky. You just gotta look at the formula. So, when referencing the entire domain, 1, the graph will extend from quadrant 2 to quadrant 1. Yep. B, the domain will be G, or domain is T is an element of real numbers. Yep. Characteristics of periodic, exponential, and quadratic functions. This is something that S to T shares. Another one is that t as an element of negative infinity to 0 looks like a quadratic function. This is like a normal parabola, which is nice. But then while t is an element of 0 to infinity, so 0 and onward, it looks more like a quadratic plus sine function combined. So D, exponential functions can never be negative. Yep, this is true. And E, exponential functions have asymptotes, but S of t doesn't. There are no asymptotes here because this is still going over to negative infinity and infinity. And one more, f. The sine part of the function is exponential, and it will continually get compressed from 0 to infinity. Notice here how it starts pretty balanced, and it just starts compressing until we get a thick, scrunchy line. So, the quadratic function does not exponentially increase on the right side. It's the power inside the sine term that is only exponentially decreasing the period and compressing itself. So there is a t on the outside of this bracket, and there's also a 2 to the power of t, which is causing that compression. If you didn't have that compression, this would look like a perfectly normal sine function. So we've gone over that. To summarize everything up, A is just asking from the stress ranging from September 1st to December 1st, which is at a rate of 2.698 stress units per month. B is asking for IROC, so Mr. Shin's stress at November 4th decreased exactly negative 5.431 stress units per month. There is a negative there, I don't know why it's missing. C, AROC increases between T as an element of 0 to 3, while IROC at T equals 2.1 decreases. D, Mr. Sin's stress changes could be due to the increase in marking assessments and specifically a strike occurring on November 4th, which could have caused those trends. E is that the characteristics of functions affecting the graph. So, such as periodic, quadratic, and exponential functions. These all play a role in how this thing turns out. We do not have misconceptions. I think we might have went over them in here, but oh well, I already went, suckers.